Okay, so now a continuation of tutorial sheet 5, but now we are on the question 2. So on question 2, what are we looking for exactly? This is under work energy theorem, which states that the work done on the object is equal to change in kinetic energy. So on here, what are we looking for? Question 2 says a driver of a 100 kg car traveling on the estate at 35.0 meters per second slammed on his brake to avoid hitting a second vehicle in front of him, which had come to rest because of the collision ahead. The first question says, after the brakes are applied, a constant friction force of 8,000 newtons acts on the car. Ignore air resistance. At what minimum distance should the brakes be applied to avoid a collision with the other vehicle? So in here, we use what we call the work energy theorem. So what does the work energy theorem? Work done on the object is equal to change in kinetic energy. So in here, remember that the force that we're using to hold this car was under friction, right? So this means that this is the work done by what? Friction force, like that. So what's the formula? It is work done by friction is what? Friction force times the change in displacement, like that, equal to kinetic energy. Remember kinetic energy, right? So it will be kinetic energy, what? Kinetic energy at the final, v squared, minus kinetic energy at initial. So we have to do kinetic energy at initial, like that. So what do you do? The next thing that you do in here now, we put, so remember that the force that was used, it was friction, so it will be 800, that was friction there, times c, that is the change in what? Displacement, equal to 1 over 2. Then what was the mass of the car? The mass of the car was 1000. And what is the final velocity? The final velocity, we don't have. Why we don't have? Because we're still moving, so we don't have final velocity. So meaning that to be just what? 0 squared. Then 1 over 2. What's the mass? It's 1000, like that. And what's the velocity or the initial velocity? It is 35 squared. So this means that I have 8,000 equal to this part here. It will give me 0 minus, then I'll say 500, like that, because I'll divide 2 into that. So it will be 500 there, right? So after doing that, what is the next thing? The next thing that you need there is this 500 times 35. So 35 squared. What is 35 squared? 35 squared, it is 1225, like that. So it will be 8,000 equal to. So there, what you do next, you say 500 there, right? Times 1225. So this means that it will give me 6125, like that, 00, like that, right? Then remember that there was a change in displacement here. Sorry for that. The change in displacement, then the change in displacement here. So equal to. So in here, what do you do? Here there's a negative, so it will be negative 8,000, like that, divided by negative 8,000, like that. So meaning that the change in displacement in that situation, so we have negative and negative, they'll divide. So since there they will divide, right? So there, what you have, right? What you have there, it will be what you have there after dividing, because it will be divided by what? 8,000. So what you have there, it will be 76.0 6 meters. That's what they are looking for. Simple and what? Straightforward. Okay, now after we have done that, let's go to 2. If the distance between the vehicle is initially only 30 or 30.0 meters, at what speed would the collision occur? So in short now, initially speed was 30 and they're saying at what speed would the collision occur. So this means that we are looking for now the final velocity, right? The time that we the time that we will the what the time will the time or the speed at which the collision will occur. So meaning that in that situation, I will do the same thing, the same formula, right? Work done, which is by friction, equal to change in kinetic energy, like that. So meaning that work done there equal to 1 over 2, then mv squared final minus 1 over 2 mv squared what? Initial. So in that situation, I'll say negative there, right? Negative what again? Force, which is friction times the change in what? Displacement, equal to 1 over 2, then mv squared final minus 1 over 2 mv squared initial. So in that situation now, what is the friction force? It is 8,000, sorry. Then what is the initial distance? The initial distance is what? 30, like that, equal to 1 over 2. What is the mass? The mass of the car is 1,000. 1,000 here. So you put 1,000 there, right? Then v squared final minus 1 over 2. What's the mass? It is 1,000 there. And the car was moving at what speed? It was moving at 35 squared. So what do? I will say 80,000 times 30. So what will be the answer this side? It will be negative 24,000. Negative 24, that is 0, like that, right? Equal to. So it will be 500 there, right? Which is final squared minus. When I multiply this side, everything there, it will give me 6,125,500, like that, right? So what I'll do is that I'll put the like terms together, which is negative 24, 240 in short, 1,000, then plus 6,125,000, like that, right? Equal to 500, which is the final this side. So what do you do there? You subtract. What answer are you going to get? You're going to get 745. Then you 500 v squared. So what do? You divide by 500. I'll divide again by 500. Then x there. So meaning that I'll have to find that, right? When I divide there, what answer I'm going to get? I'm going to get wait. I think I've made a mistake here, because here when you divide, when you subtract here, let me do this. When you subtract there, the answer I want to get that one. So when you subtract there, the answer is 372, then 500, then equal to 500, then v squared final, then divide by 500, divide by 500. So this part and that part to divide, this and that to divide. So you have 745, like that. So v final squared, like that. So what I'll do, I'll find the square root. So in short, the v there is what? In short, the v there is what? 27.3 meters, just like that. So that is how you answer that particular of the question. Simple and what? Straightforward. Okay, now let's go to the other one. The other one is saying a 5.00 grams, which is a bullet moving at 600, penetrate a tree chunk, to a depth of this, right? Use the work energy theorem to determine the average friction force that stops the what? The bullet. So in short, we shall use the same method, right? Work done equal to change in kinetic what? Energy. So meaning that this work done that will be able to stop the bullet, it will be the work done by what? Friction force. So meaning that it will be change in kinetic energy, which is final, minus kinetic energy, which is what? Initial. So in that situation, we are going to have friction force, which is that is 1 over 2 mv squared final minus 1 over 2 mv squared what? Initial. So what do you do in that situation? The work done here, it is negative friction force there, like that. Friction force times the change in displacement equal to 1 over 2 mv squared final minus 1 over 2 mv squared initial. So what do you do in that situation? You're going to say friction force is the one that we're looking for. And what is the depth? The depth of the bullet that it moved, it was 4.00. So I'll divide that one by 100, right? So that I'll find the answer. And the answer there that you shall get is what? The answer there that you shall get, because I say the answer there that you shall get is what? 0.04, like that, equal to 1 over 2. Remember that the bullet was moving. So again, that bullet was at what speed exactly? That bullet, if you check at the bullet, was at what speed exactly? Oh, at the mass was 500, right? So you divide that one by 1000, which is just as 0.005. And that bullet was moving. It was not turning, it was moving. So it means that the final is 0. So it minus 1 over 2. Again, we do say 0.005. Then what is the initial speed of the bullet? It was 600. So you square there. So there, that is 0 there, like this, right? So you have, when you multiply there, it will be negative 0.04, like that, equal to, so there it is 0, like that, right? So what will happen? It will be 0.5 times 0.005, like that, right? Okay, which is that, right? Then when you do that, meaning that when you do that, so then what's the next thing? The next thing that you should do there is this. The next thing that you shall do there is what? 0.5 times that, then times 600, which is squared. So you shall find the answer to be minus there, which is what? 900, like that, right? So after finding the answer to be 900, what do you do? I'll divide that one by 0.04. Then again, I'll divide that one by 0.04. Why am I doing that? I'm calculating the friction force. So there, the friction force, I'll divide that by 0.04 there. So meaning that my answer is 22, then 500, like that. So that is the newtons that is there. That's what they're looking for. That's the friction force which they're looking for. Now, let's go to the other one. They say assume that the friction force is constant. Determine how much time it lapses between the moment the bullet enters the tree and the moment it stops. So in that situation, what do? We have to find the acceleration, right? So to be ma, like that. So what do you do? Remember, that's a friction force, so it would be negative 500, like that, equal to, like that, right? What's the mass of the bullet? It is 0.005, like that, right? Then then you divide, like that, right? So it'll be 0.005. Then I'll make the acceleration to be subject to the formula. Then there, and this will go. So I'll have the acceleration to be what? I'll divide that one by 0, 0, and 5 there. So I shall find that my answer there it is 5 times 10 to the power negative what? To the power negative 6, something like that, right? So that is the answer that I've gotten, because that is 22, then 500 divided by 0.05. So that is the power 5. So that is the power 5. So that's not a negative, but it's just 22 to the power what? 5, like that. So I have put what here? 5, right? That's the one that I have calculated there, right? Then after doing that, let me just I think the best way to use, if I use that one, it will have a lot of errors. Let me just use this one, 4.5 there, times 10 to the power 5, like that, meters per second squared. So then after that, what do you do next? I'll go to the formula. Remember that this is negative, right? So I'll go to my formula. Velocity final equal to velocity initial plus at. So what's the velocity final? It is 0. What's the velocity initial? 600. Then plus, what's the acceleration? It's negative 4.5 times 10 to the power 5. Then time. So what will happen? It will be this. Let me just remove these ones here. So what will happen here to be this? It will be what will happen to be negative 4.5 times 10 to the power 5 t there, right? Equal to negative 600. Then I'll divide negative there. 4.5 times 10 to the power 5 divided by negative 4.5 times 10 to the power 5. So what will happen? It will be t is equal to, so it will be 600 there, divided by that answer. So answer, it will be 1.33 times 10 to the power times 10 to the power 4 seconds. Just that's how you answer that particular type of what question. That's all, just like that.